All right, I hope you pushed pause and did this problem. If you haven't, go ahead and do that. We are going to find the indefinite integral of 4x plus cosine of x with respect to x. Again, I want to reverse the derivative process. This 4x is a polynomial, so I'm going to raise the exponent by 1 so that when I do a derivative, it lowers the exponent by 1 and matches just x. And then the coefficient will be 4 divided by 2. That way, when I multiply times the exponent of 2, I end up with 4 in the front. Then I ask myself, what trig function has a derivative of cosine? This one's pretty straightforward. The trig function whose derivative is cosine is positive sine. When I take a derivative of sine, I get a positive cosine. And then I can tack on any constant that I want. Make sure when you're doing this that if you write this in Moodle, your C, your constant C, is capitalized. It will be case sensitive, I believe, in Moodle. If you want to simplify this further, you could have easily said 4 divided by 2 is 2. So you could have called that 2x squared plus sine of x plus c. You may recall that I said any antiderivative would have worked and then tacked on a plus c. If you said, let's let the antiderivative be 2x squared plus sine x plus 13 and tack on an arbitrary c, well, notice that 13 plus c is just a constant anyways. So you can replace the 13 plus c with just the letter c. And this is what's traditionally done. Traditionally, the only constant that you use is the c, and you don't use any other constants in the antiderivative. In some sense, you use the antiderivative with constant 0, and then you tack on a plus c at the end. Again, that's sort of the traditional way it is done. So that is this problem. You can see that the techniques that we're using are essentially just thinking through how to reverse a derivative. So a lot of our rules that we're going to see of finding an antiderivative or finding the indefinite integral will simply be reversing the derivative processes that we learned earlier.